Okay, so the important bit is with a criterion B, okay, criterion B is all about pattern spotting, but actually it's about generalizing the patterns. And it's not really a pattern in this case, it's a can you generalize what you do. Right, so it's a bit, although it says investigating patterns, it's about can you develop a method. So in this case, what you guys did, and I can cheat a bit here, put my grid on. Right, I see you all, you've done your grid. I'm going to make life a little bit easier on myself. And I'm going to go, right, here's a point, and my point is at 1, 1. And I'm going to pick another point, and that point is at 7, 5, yeah? So I've got 1, 1, 7, 5. Now, obviously, a lot of it relies on me getting coordinates the right way around. You're not going to draw this because you've got your own version, right? The distance between the 2 points is that. I'm showing I understand that. And then, well, what did you do? So you would make a triangle. Yeah. And then we go, well, it's from 1 to 5 is 4, from 1 to 7 is 6. Now, that's the point where I did say yesterday, have another think about how you get that number. All right? Because it's quite, this is the way I've just done it, is a very visual. I said I'm a very visual person. That's how I like to see it. I draw a bit. But there is another way of doing it. But anyway, we'll get to that point, which is we then do 4 squared plus 6 squared equals, well, like we did, called it AB, so AB squared. So you're going to put more detail in here, which is 16 plus 36. We square root that. That gives me AB. So we've got the distance AB is the square root of 52, which you can work out. That's fine. You're all good at that point, right? Yeah. Is that what you're up to? Come out at that stage. You're there. All right. Now, sorry, camera, we'll come back in a sec. This says, using general points x1, y1, x2, y2, generalize your finding to find a formula for the shortest distance between any 2 points. Why shortest distance between any 2 points? Well, that is the shortest distance between any 2 points, right? A straight line between those 2 points. I don't need to make a big deal of that. I guess what we're getting to, though, is if we take these numbers away, all right, we take those numbers away, what we get left with is this. Even if I draw a grid, and let's say I put my points in the same place, all right, but there's no numbers on the grid. This coordinate, so this point has coordinates x and y, yeah? This coordinate is also x and y. You know x comes before y, right? Yeah. It's always that way around, always. So I'm already using one generalization there. I'm already saying it's always x and y. But there's a trouble with having x and y, which is, well, I need to know the difference between those. So I'm going to call this one x1 and y1 for the first point. And this one is the second point. So I'm just going to say it's x2 and y2. If I had a third point, it would just be x3 and y3. Now here's the thing. This is what my grid could still look like. There's my straight line. If I was going to do a grid, this would be x1. This point here would be x2. This value would be y. This would be... Okay. The question is, here's that length there, which is basically going between x1 and y2, and here's that length. So I want to know what the length is between those 2 coordinates. How do I find that?
I think I might have it the wrong way around, but would it be like x1 minus x2?
Okay.
Yes, you are.
So you're right in that it is the wrong way around. Okay. But actually, it doesn't matter when we go carry on. we'll see why in a bit. But yeah, what do you think, guys? This distance here is actually x2 minus x1. What do you think about doing that? Make sense?
If x2 is a negative and x1 is not negative, then it we just
Doesn't
use
change.
absolute value,
No,
right?
it doesn't change. We'll talk about it in a sec. Right, this one, y2 minus, now is anyone looking at that and going, I have no idea why? Look, if we go back to here, look. What's the difference between 7 and 1? Well, you just look at it and say 6. But look, 7 minus, the reason is, 7 is that distance, yeah, from 0.
Yeah.
1 is that distance. 1 is that distance. How do I find the distance between them? Subtract, right? Take that 7 and subtract the 1. I'm left with 6. That's what you do, right?
Yeah.
So, we go back to this. That's x2 minus x1. This is y2. Now, transfer it to my triangle. y2 minus y1. x2 minus x1. And what do I do to find the distance? x2 minus x1
Squared
squared
plus y2 minus y1 equals ab squared.
square root. That gives me the distance, no?
Yeah.
Done.
Yeah.
That's what I do every time, isn't it? Every time I want to find the distance between 2 points, I find the distance between the x points, square it. Find the distance between the y coordinates, square it. Add them together, square root it. Don't we do that every time?
Yeah.
Yeah.
We do.
Do you see it, guys? Make sense? So really, what we're working on here is your ability to go from knowing what to do with some numbers to
Knowing what to
actually
do with it.
explaining without numbers what it is actually happening. And that's the thing that worried you all, I think. It was like, I don't know what I'm writing. Even though I'm pretty sure you all knew how to do the actual maths, right?
Yeah.
Pythagoras theorem, just you all did that. Question 1, no problem, straight away. Right? It's just generalising it. And I think you thought it was much more than it actually is. It's just about writing down what you're doing. That's why this is actually quite a nice task, because it's an easy one to see. Right? Wow, like computer, I'm not even touching that. Alright. I am still recording. So once we've generalised, we've got a formula that we think works. We think it works. If you're still feeling like you need to write this down, by the way, you know I'm recording, so you can do this at home. The next question says, verify that your formula works for 2 or more pairs of points. Here's my suggestion. My coordinates for part 1 were 1, 1 and 7, 5. So I'm going to check. Point A was at 1, 1. Point B was at 7, 5. So I'm going to say x1 is 1. x2 is 7. Now, you better not be writing mine, because you've got your own numbers, right? You should be putting your numbers. And then y1 equals 1, and y2 equals 5. So in my equation then, I'm going to put 7 minus 1 squared plus 5 minus 1 squared, square rooted. So that's 6 squared plus 4 squared, square rooted is the square root of 52 again. And I can say same as party hat. I was just about to draw one of those streamer things, and I thought, no, that's going to look like he's smoking. So that won't. So the important word here is verify, and now I've kind of said to you over and over again, how do I get verification with calculators and you guys? Why do I say it's important that you all do the calculation?
You are.
And if you're the only one that does it, and you just happen to press one button by mistake, and we go with your answer, we're all wrong. But if you do it, and Hugo does it, and Simon and David does it, and Connor does it, and then everyone else gets the same answer but it's different from yours, we would go with the one that most people got, yeah? Or at least that means you would check. So when you verify, it's not just about doing another one, you're actually checking your method works. So that's why I used question 1's example. Alright, question 1's example. When it says use another pair, what am I going to have to do?
Make new numbers.
Make new numbers, but not just stick it in here. I'm going to also have to show the grid method roughly, aren't I?
Oh no.
Yeah? Doesn't have to be secret. But this is where, in a criterion B, as you get later on, this is where you get the bigger marks. Because each question requires just a little bit more on top of each other. Right? But you get the point. Verify means check with both methods. Because if we decide a formula is what we think it is, and then we check it with one and it works, but I check it with a second one, it's like, ooh, it doesn't work. So David was saying, for instance, that something about if one of the points is negative, all right, we have to do something different. Absolute values. All right, so that would be something to think about. But let's have a go at another set of points. So let's just say if I put negative 3 at 5, and I'm going to put 7, negative 4. All right. Now this is one of the ones that I struggle with in my head, because I'm visual and I like to see it in a grid in front of me. But actually, doesn't matter with the distance formula. Which one's which? Which one has to be x1 and x2? Does it matter? It doesn't matter. I can say this one is x1, y1 if I like, and this is x2, y2. Why can I do that? Well, let's just have a look. So x2 minus x1 just happens to be negative 3 subtract 7. And y2 minus y1 is 5 minus negative 4. And I get the answer, negative 10 and 9. All right? Now David says this needs to be taken as the absolute value. And he is right, a distance is an absolute value, but why don't I need to worry about it when I'm doing Pythagoras' theorem? Anyone going to take the high honours at the end of our class?
Because triangles can't have a negative area.
Well, I've got a negative, it's nothing to do with area, it's a distance. Do I need to take into account the negative, or can I just carry on? Why? Which bit's important? No, wrong bit. Negative 10 squared plus 9 squared square root. Negative 10 squared is?
Negative 10.
Negative 10 squared is positive 100. The same as positive 10 squared. Why is that? Because a negative times negative is positive, so I don't actually need to worry about it at all. I could take the absolute value, but I don't need to worry about it because of the squaring. Justify it? Well, that's another day.
Subscribe.